refreshed our memories on logarithms. Today we're going to do a couple challenging logarithmic problems, and then next section we'll jump into derivatives. So hopefully by the end of today you'll be able to solve any and every logarithmic problem you run across, except for derivatives. Suppose the graph of y equals log base 2 of x is drawn on a coordinate grid where the unit of measurement is an inch. How many miles to the right of the origin do we have to move before the height of the curve reaches 3 feet? Now, let's talk for a second because it says the unit of measurement is an inch. So we can't use 3 feet, we have to use 36 inches. And we want to know when log base 2 of x is going to get to a height of 36 inches. So, in order to solve this, we change the form. And we get 2 to the 36 equals x, which means x is 68,719,476,736. And that is inches. We run in inches. If you convert, dividing by 12, dividing by 5,280, that's 1,084,587.7 miles. That'd be a big graph. The geologists C.F. Richter defined the magnitude of an earthquake to be log base 10 of I over S. I is the intensity of the quake, measured by the amplitude of a seismograph 100 kilometers from the epicenter, and S is the intensity of a standard earthquake. The 1989 Loma Prieta earthquake shook San Francisco with a magnitude of 7.3 on the Richter scale. The 1906 San Francisco earthquake was 16 times as intense. What is its magnitude on the Richter scale? So, a little bit tricky, but we're going to be okay. We know that log base 10 of I over S is equal to 7.3. Which means, from here, we need to find out what would happen, or what this equals, because they said log base 10. This is the San Francisco Loma Prieta earthquake in 1989. So I'll just put a little 1989 so we know. We're trying to figure out what the 1996 earthquake equals if it says it was 16 times as intense, which means log base 10 of 16i over S is what we're trying to evaluate. Now, be careful as you work this out because I can tell there are two unknowns. It's going to be hard to get a number when we have two variables that we don't know. But I'm going to break this up. Be strategic when you think about this. I'm going to break this up into log base 10 of 16 plus, because it's multiplication, log base 10 of I over S. Now, I know from this, up here where we talked about the 1989 earthquake, that's equal to 7.3. And log base 10 of 16, I can figure out in my calculator, and I can find out that this is approximately equal to 8.5, because log base 10 of 16 is about 1.204. Our answer is an 8.5 on the Richter scale. Find the domain and range. Well, let's talk for a second. Domain of a logarithm is everything inside of it has to be greater than or equal to 0. You saw our graph on yesterday. It is only to the right of the y-axis. So, our e to the t minus 2 has to be greater than 0, which means e to the t has to be greater than 2. Sorry about that. Greater than 2. We can't change the form because it's not an equation and we don't know what way that inequality sign should go. But I can take the ln of both sides. If I take the ln of the left-hand side, ln base e of e to the t is equal to t. And the right side stays ln of it 2, so I know that our domain of this function has to be from ln of 2 to infinity. Because this function was translate it, right or left. Right in this case. Now, domain, it was only changed left and right. It wasn't changed up and down. Even if it were changed up or down, it doesn't matter because our range is all real numbers. Because the natural log goes from negative infinity to infinity when we're talking about y values. All right, find the inverse function of. Well, to find an inverse function, we switch our x and our y. So x equals 2 times 10 to the y. Now, I am trying to solve for y. In order to get it out of the exponent, I have to change form. So this would become log base 2 of x equals 10 to the y. But now I still need to get y out of the exponent, so I'm going to have to change the form again, which means I'm going to have a log base 10, because 10 is my base, of log base 2 of x equals y. Similar idea over here. We're trying to find the inverse. Switch your x and your y. I'm going to go ahead and square root. And I know that I don't need a negative because they're telling us that x is greater than 1. So it's square root. I don't have to put a plus or minus if we only want the plus. We got to get the y out of the exponent, or out of the logarithm, I'm sorry. So we need to change the form. E to the radical x equals y. And there you have it. Basic steps for finding an inverse. Switch your x and your y's. Solve for your y. Questions? Star some things on your notes if you have questions. Bring them with you to class tomorrow.